Hi, this is Mr. West, and today we're doing a walkthrough video for Solve the Equation Sheet 1. This is from Math-Salamanders.com. Make sure to check out Math-Salamanders. They have some of the best math templates and worksheets on the internet. So let's talk about what we're seeing here. So we're seeing a bunch of equations, and we know they're equations because they all have an equal sign. Expressions do not have equal signs, but equations have equal signs. That's because they have the same root word. But what is this all talking about? If you've never seen a variable before, let's quickly talk about that. So a variable by itself is an unknown value. It could vary what it equals. That's why it has the name variable. And we really don't know what it equals on its own. But if we're given some clues, for example, let's look at x plus 1 equals 10. Well, now we have some additional evidence and we can find out exactly what x equals. So again, by itself, this is just an expression. Let me get rid of the equal sign. This is an expression. We don't know what it equals. It could equal very much anything. But when we have it set equal to something in an equation, most of the time we can find out what it equals. So in this case, we obviously can. And there's a process to solving that so we can always arrive at the answer. How does that work? Well, here we have all of these problems, and I believe most of these are one-step equations. There might be a few two-step ones further down. Yes, there's like one or two of them, and I'll talk about those in a second. But first, we got to just start with the process. And actually, I would actually recommend getting some space to write in. So if I had my equation 8 minus 1 equals 7, I just cleared off, this is like my blank piece of paper I would start with if you're not comfortable with it yet. We have 8 minus 1 equals 7. What we need to do here is we need to understand that we are starting with an unknown. We're doing some sort of operation. And then we have our finish or our end. And we know what the end equals. We know what we do with the operation. We just don't know where we start. So how does that work in terms of finding out where we start? A lot of you will be able to do this stuff in your head. Think of it this way. We have question mark minus 1 equals 7. What is the question mark? A lot of you might be able to figure that out really easily. But let's say, whoops, let me go backwards here. But let's say we can't find the answer. We're struggling with the process, or maybe we're into an equation that's much more complicated than this. What we need to do is we want to go backwards. So if we know our end and we want to go back to the finish, think of it this way. We have some amount of money, we spend $1, and we know we end up with $7. Where do we start? Okay, well, we started, how to find where we started is you're going to add that $1 back to your end amount to figure out what your starting value was. So the key to this process is going in reverse. And when you go in reverse in math, you're going to use the inverse operations. So if we're going to add, the inverse operation is going to be subtract. If we subtract, then the inverse is going to be add. And the same thing goes for multiplication and division, and of course division and multiplication. So those are the inverses. These inverse operations help us to solve all these problems. Let me show you what that looks like. So first off, one of the principles of equations is they need to be balanced. Just like a scale, whatever we do to the left side, we have to do the right side because we don't want to create an imbalance. For example, this is just a quick explanation. If we have 10 equals 10, that's true. But if we add 1 to the left side and not the right side, this is not true. That's bad. So if we have 10 equals 10, we want to make sure whatever we do to the left side, we also do to the right side. That way, it remains balanced and we're good, okay? So we want to do inverse operations. We see that we are subtracting 1 from our unknown starting amount. So we want to do the opposite to undo it, to go backwards to see where we started. And in this case, we get A. Now, the minus 1 plus 1. This is probably the most confusing part for students. If we have minus 1 plus 1, we do the inverse operation, it cancels away. Why does it cancel? Well, if we have A minus 1 plus 1, well, minus 1 plus 1 is equal to 0, and A plus 0 is just A. We effectively get it by itself, and that's your goal. We want the variable by itself so we can figure out what it is equal to. So we have A by itself on the left side, and we're done with the left side's operations. Now we have the right side's operations. We have 7 plus 1 equals 8. I'm guessing most of you said, oh, I know 8 minus 1 equals 7. I didn't need to do all that. I understand that. But I'm asking and telling you that if you understand the algorithmic process for solving these equations, it's really going to help you when they get a little bit more complex. So understanding you have to do inverse operations to get the variable by itself is important, and it's very critical to understanding the basis of algebra. So here we have another one. Let's skip down to number 3. We have 2 times c, and I'm changing that to a dot here. That's just what I do in my class. So I have 2 times c equals 14. And I see that I can read it as 2 times some number equals 14. Again, you might be able to do that in your head. But for me, I'm going to follow this process. I want to undo that times 2. I want to get the variable by itself. So I need to undo that multiplying by 2 so that I end up with this. That's what I want. So how do I get there? Well, I undo that times 2. So I divide by 2. And what happens? Well, if I have 2 divided by 2, well, that equals 1. And you're probably saying, but that's 1 times c. It's not by itself. That is equal to c. 1c is equal to c. Effectively, we got it by itself, even though it doesn't quite look like it. So anytime I do an operation, an inverse operation, I'm going to cancel away the thing that I inversed. So in this case, the multiply by 2 got canceled with the divide by 2. And then we just drop down our c, and it stays by itself on the left side of the equal sign. Now, you're probably saying, you imbalanced the equation. You just divided 2 to the left side. That is correct. So I need to fix that by dividing by 2 to the right side also. So we have 14 divided by 2, and that equals 7. Now, one thing that's important to do also is to check your answer. This is going to be important later on when you have 4 or 5 steps and you're not sure if you made a mistake somewhere along the way. But with simple one-step equations, it's kind of redundant to check your answer, but it is important to understand the process. So that's a weird-looking 7, but that is a 7. 2 times 7, does it equal 14? All I did was replace this c, let me highlight it, with the value that I found c to be. So we know that c equals 7. So I just plugged it in and I get 2 times 7. Does it equal 14? Yes, it does. So I know I got the correct answer. All right, let's move on. I'm trying to find another operation we haven't done yet. So we did subtraction. How about addition? So we have d plus 4 equals 14. Let's do that one. I'm going to change it to blue just so we can keep it straight. Okay, so d plus 4 equals 14. Addition ones I think students are the most comfortable with, and then all the other operations students are a little bit more uncomfortable, like subtraction. I'll show you what happens in a little bit. So this is a common mistake I see. So I wanted to mention some common mistakes. And one of the most common mistakes I see, I'm going to keep it blue actually, is actually I'm going to change it to red because this is a common mistake. I see students do this. Oh, it's plus 4 and 14. I'm going to do 14 plus 4, and I have 18 as my answer. That is incorrect. What they did is they added across the equal sign, and you can't do that. Instead, we need to think something plus 4 equals 14. Well, we don't know what that something is, so we have to go in reverse from 14. And that means that we are going to do the inverse operation if you want to go in reverse, subtract 4 to both sides, and then we can cancel out the plus 4 and minus 4, and we're left with just the d by itself. Now we have 14 minus 4, and that equals 10, and that's going to be our answer. Does 10 plus 4 equal 14? Yes, it does. So we know we got the correct answer. Okay, so that's the answer for that one. Let's go here to number 9. Number 9 is tougher than it looks. Let me talk about it. So we have, this is actually a 2-step equation. All right, so number 9, we have 10 minus I equals 3. This one's different because instead of the variable being at the start, it's in the middle. It's the one getting with the operation. So you might be able to do this in your head. 10 minus what equals 3? Well, I know it's 7. But what happens? Well, first off, we need to identify what is happening to I. Some people think, oh, it's subtracting. So we're going to add 10 to both sides. That would be incorrect, because if you add 10 to both sides, let me show you what that looks like. Incorrect. This is the incorrect path. Okay, just so you don't do this. 10 minus I equals 3. If you, I need to add 10 to both sides, I get I equals 13. Does 10 minus 13 equal 3? No, it doesn't. That is incorrect. So we messed up. Okay, that would give us a negative answer. So we need to do something else. Instead, we need to do an inverse operation from positive 10. If that doesn't have a sign in front of it, that's really a positive 10. So we have to do the inverse of positive 10. What's the inverse of positive 10? Subtract 10. So we have to subtract 10 from both sides. That cancels out that. And on the right side, I don't know if you guys have covered this yet in your math class, we haven't in mine currently. We do 3 minus 10, and that gives us negative 7. And then we have the minus I still there. We drop everything down. Everything we haven't undone, we drop down. So now we have minus I equals minus 7. We could read this as the opposite of I equals the opposite of 7. So I hope that makes it clearer what we do next, okay? So if we the opposite of I equals the opposite of 7, then we could therefore hypothesize that I equals 7. And that's the correct answer. But how do we get there using steps? What we're going to do instead, let me kind of white out. I don't know a good way to do this. What we can do instead is we are going to, which one did I use? Probably this one. What we're going to do is we actually have a second step. This could be considered a negative, whoops, not that one. This could be considered a negative 1 times I. I think I used one smaller. There we go. So a negative 1 times I is the same thing as negative I. Those two are equivalent. Okay, so equals negative I. So if you have a negative 1 times I, we're going to do divide by negative 1 to both sides to solve for it. So I hope this isn't over your head. This is kind of a little complex concept woven in here, but I just wanted to make sure I'm clear and consistent in how I would answer this. So a negative 1 times I divided by negative 1, we're going to have the negative 1's cancel out, and we're left with just I. Then we have negative 7 divided by negative 1, and that equals a positive 7. So if that is, again, whoa, that's way too much information, that's okay. Just go back to what do I subtract from 10 to get to 3, and that is 7. So 10 minus 7, does it equal 3? Yes, it does. Okay, that's how I would approach this problem. Let's maybe do like one or two more, and then let's call it good. Okay, so let's see here. Let's do number 15. That's an arrow. So we have O. You gotta be careful with O's. They kind of look like zeros. Divided by 2 equals 6. Now you're like, whoa. You wrote it as a fraction. It's the same thing. So if I have O divided by 2 equals 6, it's the same thing as that fraction I just wrote. These two are equal. Okay. Most often in upper level math, you're going to see it like this. But again, it doesn't matter. So let me just actually write it the original way and then go from there. So if I have divide by 2, I want to do the inverse operation, and that is multiply by 2. And it's the same thing we had earlier. If we have divide 2 times 2, essentially what you get is 2 over 2, and that equals 1. Okay, so if you have O times 1, I'm just going to write it like that, equals, and that's on the left side, we have 6 times 2, and that is 12. O times 1 is the same thing as 1 O. It kind of looks weird, and that's why we get rid of the 1 and just put it O equals 12. 1 O and O are the same thing. If you have 1 O, then you just have an O, and there's your answer. Does 12 divided by 2 equal 6? Yes, it does. Okay, let's do one more. Another actually pretty tough one is number 23. So if you're going to use the same method, 25 is also a little tough one. Anyone where the variables in the middle of the two numbers, that one's going to be a little bit more difficult, but 23 also. So we have 23 divided by W equals 4. This is tough because you're like, what operation is happening to W? It's hard to know. That's why writing it as a fraction is a little bit more useful. So we have 20 over W equals 4. 20 divided by something equals 4. Well, you could just be like, okay, I know that 20 divided by 5 and write that as your answer. But if you wanted to be thorough with your math, This would be the way that I do it. So anytime I have a fraction with a variable in the bottom, I want fractions on both sides, and I'm going to set up a proportion. This is like 4 chapters of material that I'm doing like in 30 seconds, so just giving you a heads up. And then I'm going to cross multiply here. This is one method for solving when you have a variable in the denominator. What happens when you cross multiply? And if this is confusing you, there's other ways I can show you. So we can cross multiply here, and we get 20 times 1 equals 4 times w. So now we have 20 equals 4w, and then I can divide by 4 to both sides, and I get w equals 5, and I get the answer that way. Okay, now that was a lot. There's another way you can do this. Equals 4. Okay, so what I can do instead is I can say, okay, I have divide by w, and I don't want it there. So I can do the inverse of that to cancel the w's on that side. But again, if you times w on one side, you have to times it on the other side. So I can cross those out. W divided by w is just 1. 1 times 20 is just 20. So I have 20 equals 4 times w. 1 times 20 equals 4 times w. That's exactly what I had earlier. Okay, so if you're wondering, like, why can you just cross multiply? That's effectively what you're doing when you're trying to get w not to be in the denominator. So I have 4w over here, and then I have divide by 4, because that's the inverse operation, and I get 5 equals w. And I could check my answer and do 20 divided by 5, and that equals 4. Okay, so that was a lot. That was actually probably all the way through 7th grade math. If you are currently in 6th grade, there's a lot of information. Otherwise, the main thing I want you guys to get out of this video is the structure is going to be important later on. So although you can do it in your head, okay, you would definitely benefit from showing your work and having some structure in place. If you're going to use the template here, my recommendation would be give yourself some space. For example, put it like this. Okay, and then know that you need to show the opposite operation to both sides. Divide by 4, divide by 4. Those are going to cancel, and then you have n equals 7 for number 14. That is just a bonus one. So I hope you enjoyed this video. If you have any questions on it, make sure to leave a comment below, and I look forward to seeing you next time right here on Wes Explains Best.